Hello everyone, welcome back. Today in this video we are going to discuss remaining questions of Specimen paper 2021 Mathematics AAHL paper 1. We have discussed the first 7 questions in the previous video. So in this video we are going to discuss the rest of the questions. So let's get started. And here is the question number 8. The plane pi has the Cartesian equation 2x plus y plus z equals 2z equals 3. The line L has the vector equation r equals 3, negative 5, 1, which is of course the position vector, a point on a line, and plus mu times 1 minus negative 2 p, that is the direction vector of the line, where mu and p belongs to real number. The acute angle between the line L and the plane pi is 30 degree. The question is to find the possible values of p. So here the informations, from the given information we can see we have a plane pi and a line, and the angle between the line and plane is 30 degree. So here we know the angle. Whenever we talk about the angle in the vector, we need two vectors to figure out the angle. And here if we see that there is a line, this L line and pi, we have from the pi we have a normal vector. From here we can get the normal vector, because whenever we have a plane we have a normal vector to it. So from here we get one vector, and from L, the line, we have a direction vector which is 1, negative 2 and p. So we, in order to see the angle between line and plane, we will see the angle between line and the normal to the plane. So it's very obvious that when you have the normal to the plane, it is perpendicular to the plane here, and suppose there is a angle, there is this line going, and that this line L makes the angle pi with the plane, angle 30 degree with the plane. Then at the same time, which makes 90 degree, the normal makes 90 degree with the plane. So this angle between the line and the normal has to be 60 degree. I'll take the help of software to visualize it. So here we can see that this is a plane. We can see it's a plane, and the pink line is line L, and there is a green line which is a vector, normal vector to the plane. So from here we can see the angle between the plane, and the line is 30 degree. At the same time, the angle between the normal and the plane, normal and the line, will be 90 minus 30 degree, which is going to be 60 degree. So that's what we are going to use here. So now we will take this question as the angle between the two lines as 30 degree. So first angle is 90 degree. First angle is normal. We'll take it as n vector, and we know from the plane the normal vector is the coefficients of x, y and z. That is going to be 2, 1 and 2. And the from the line, we can take I'll take normal vector as a here, and b vector as the line vector parallel to the line, which is of course the 1, negative 2 p. So it is 1, negative 2 and p. So if the angle between vector a and vector b is 60 degree, so we can see the angle between a and b is 90 minus 30 degree, which is 60 degree. So we will use the formula dot product a dot b equals magnitude of vector a, magnitude of vector b into cos of the angle between it. Let's take it as theta. So from here we have a and b, so we can calculate first of all what is a dot b. So in the dot products we take the corresponding numbers and multiply it. 2, 1, 2 dot with 1, negative 2 p. So this is going to be 2 times 1, which is 2. 1 times negative 2 is negative 2, and then plus 2 times p. So finally we are left with only 2 p as the dot product. And if we talk about the magnitude of vector a, this is going to be square root of 2 square component square, that is 2 square, 4 plus 1 plus 4, which is 9, and square root of 9 is 3. And now for the b vector, the magnitude of vector b is going to be square root of first component is 1, so 1 plus negative 2 square, which is 4, plus p squared. So this become 5 plus p squared, square root of it. So we have and what, of course, the cos theta, if we include that too for the calculation. So cosine of 30 degree, sorry, not cosine of 30 degree, it is 60 degree now. So cosine of 60 degree, we know it is 1 over 2. So we'll use these values here and plug it in the main formula. So we got it as 2p equals 3 times square root 5, this is 5 plus p squared multiplied by 1 over 2. Now we'll cross multiply to that side, and then we'll take the square. So it is 4p equals 3 times square root of 5 plus p squared. Squaring both the side, we'll get 16p squared equals 9 times, and squaring the square root will cancel the square root, so it is just 5 plus p squared, which can be written as 45 plus 9p squared. So I'll take 9 to the left hand side, then this become 16 minus 9, which is 7p squared equals 45p. From here we got p squared as 45 over 7, and from the question itself they have given that find the possible values of p, so there has to be 2 values, and we can get from here as well, in case we forget. Sometimes when we simplify the square, we forget the negative signs. So here it is going to be p equals plus minus square root of 45 over 7, and 45 is 9 into 5, so square root of 9 is 3, so we can finally write it as plus minus 3 times square root of 5 over 7. So that's the these are the values of p. I hope it's clear. Let's do the next question. So here's the next question, question number 9. I stretch the figure so that we can see the whole question as well as the diagram on the same page. The function f is defined by fx equals e to the power 2x minus 6 e to the power x plus 5, where x belongs to real number, x is less than or equals to a. The graph of y equals to fx is shown in the following diagram, and now they have given the diagram here. And the first question, we can see from the diagram, first of all, before approaching to the question, we can see this graph has one minimum point, and we can see it is not a 1-1 function because it will not satisfy the horizontal line test. So let's see the question, and the question A part is find the largest value of a. So it's like finding the largest value of a, for which a is a part of domain. Okay, so find the largest value of a such that f has an inverse function. So for inverse function, we see that inverse function only exists when the function is 1-to-1, and in order to make it 1-to-1, we need to restrict the domain. So we can see the question itself has given that x has to be less than or equals to a, and if we see this is the minimum point. So if we just remove one part of the graph, one part of this graph, then it would become a 1-to-1. And here as a hint, we can see x has to be less than a. So if we take the corresponding x value to this minimum point, it is going to be a here. So we need to find this value of a, for which with domain would be just the lesser values to a. So it means technically if we will not have this part of the graph would be 1-to-1, and we can have the inverse function. So for that we'll find the minimum point, and for the minimum, maximum, stationary, turning points, all these things we need to find first of all the derivative of the function. So here fx is e to the power x minus 6 e to the power x plus 5. So f dash x would be, f dash x is e to the power exponential functions derivative is exponential, the same function itself, so e to the power 2x, but there is not x, there is 2x, so we will multiply by the derivative of 2x, which is just 2, so I'll take it in front, and then minus 6 e to the power x is just e to the power x, so we got the derivative. So for the minimum point we'll make this equals to 0. So at x equals a, at x equals a, f dash of a has to be 0. So it becomes 2 e to the power 2a minus 6 e to the power a is equals to 0. So since e to the power a will not be 0, we can cancel 1, or we can take 2 e to the power a, factor out e to the power a. We are left with e to the power a minus 3 equals 0. So since this will not be 0 ever, because exponential function never gets over, never get the value 0, so this another term e to the power a minus 3 has to be 0, means e to the power a has to be 3, or we can say a has the value ln 3. So that's the maximum value of a. So that's the answer for the a part. I hope it is clear. Let's discuss the next part. So the b part, for this value of a, which is ln 3, find an expression for f inverse of x in stating its domain. So we will find the inverse first of all, and domain is like whatever the range for fx is going to be same as for the domain for f inverse x, but first of all we will find the inverse function. So if we have fx is e to the power 2x minus 6 e to the power x plus 5, so we'll have the first step as writing the fx as y, so this becomes y equals e to the power 2x minus 6 e power x plus 5. The second step is to interchange x and y value so that we get the inverse in terms of x at the last. So we got this thing as x equals e to the power 2y minus 6 e to the power y plus 5. Now the third step is to make y as a subject. For that I will bring everything one side, so this becomes quadratic in e to the power y, e to the power 2y minus 6 e to the power y plus 5 minus x equals 0. So whenever we have a quadratic functions, in order to find the inverse of it, the best way to do it by the completing square method. So we can make the completing square by these two terms. It is going to be e to the power y minus half of 6, which is 3 whole squared, and subtracting the square of 3, which is 9, and plus 5 minus x equals 0. So from here we got e to the power y minus 3 whole squared, because our task is to make y as a subject. So this thing become negative minus 9 plus 5 is 4, negative 4, other side it will become 4. So finally we got this thing as x plus 4 to the other side, and then we can write e to the power y minus 3 as plus minus both square root of x plus 4. See, we should not write directly as either plus or minus root x plus 4, because this is yet to be decided. So from here we get e to the power y as 3 plus minus square root x plus 4, or we can write y as ln 3 plus minus square root of x plus 4. So that's the last step, and now we will decide whether we have to choose plus or minus sign. So here we can see the domain for the original function fx was less than or equals to a, which was ln 3, and domain for the fx is same as the range for the f inverse x. So this function should not be more than ln 3. So it means we have to choose the negative sign. So it is f inverse x as ln 3 minus root x plus 4. So that's the expression for f inverse x. And now if we talk about the domain of this, so we can see the domain the minimum value from the function was -4. We can see this point was a comma -4. So domain for the domain of f inverse, domain of f inverse of x. So first of all, minimum value has to be -4 including 4, and then for the maximum value of x. See, if we look at the f inverse x, this is 3 minus root x plus 4, and we know the rule that input for the logarithmic function can never be less than or equals to 0. It means the root, the square root, it means 3 minus whatever is there is this cannot go below 0. So it can be till maximum it can be 9, not more than that. Otherwise you will not get a valid function of f inverse x. So for 9 we will take x plus 4 as 9 means x has 5. So from here we can see the domain of f inverse would be x greater than or equals to 4 or less than 5. Will not even take 5. So sorry, this will not even take 5. So it is going to be just less than, because when we'll take 5 it will become log 0, which is not possible. So I hope that's clear. Let's discuss the next question. So after section A, we have the first question from section B, question number 10. Let fx be ln 5x over kx, where x is greater than 0 and k belongs to positive real number. First question is, show that f prime x is 1 minus ln 5x over kx square. Means in the first part we are going to differentiate it, and we can see the fx is a quotient function. Something is there in the numerator and denominator, so we'll use the quotient rule to find the f dash x. So f dash x is going to be the quotient rule. It says denominator square in the denominator first of all, so it is kx whole square, and then denominator as such, and multiplication multiply by the differentiation of the numerator, which is ln 5x, and the derivative of ln 5x is just 1 over x, because if we use the chain rule it is 1 over 5x into 5, so we can cancel it, and minus the second function, that is numerator as such, and derivative of the denominator, and derivative of the denominator is going to be k because it is kx. Now we can cancel out something, for example x and x here, and we are left with k minus k times ln 5x over k squared x squared. And now if we cancel out k, or first of all taking k common, factor out from the numerator, it is going to be 1 minus ln 5x over k squared x squared. So we can cancel one k in the k from numerator and denominator, and finally we will get it as 1 minus ln 5x over k x squared. So that's the answer for the A part. For the B part, this is a graph of f has exactly one maximum point. Find the x coordinate of B. So they have given the information as the one maximum point, but we know that for the initial value, for either it is maximum or minimum or stationary point, turning point, we can simply start with taking f prime x as 0. At P, f prime x has to be 0. So it means we have f prime x as this 1 minus ln 5x over kx square. So if this is 0, it means the numerator is 0. 1 minus ln 5x equals 0, because we know the denominator can't be 0. So from here we got ln 5x equals 1, or we can say fx as e to the power 1. We can write just e, and then x become 1 over 5 times e, and that's the x coordinate of p. So now we'll see the next one. The second derivative of f is given by f double dash x is 2 ln 5x minus 3 over kx cubed. The graph of f has exactly one point of inflection. Likewise, in the first part, they have given that exactly one maximum point. So we have seen for the maximum point, the first condition is the f prime x was 0. For point of inflection, the f double dash x has to be 0. So we can write at q f double dash x equals to 0, means this thing equals 0. If this is 0, it means numerator, of course, it's 0. So 2 times ln 5x minus 3. Okay, we'll go to the question, and they have asked the same question, which is show that x coordinate of q is 1 over 5 e to the power 3 over 2. In the same way we have solved the b part. So this equals 0, means ln 5x equals 3 over 2, or we can say 5x equals e to the power 3 over 2, and we got x as 1 over 5 e to the power 3 over 2, and that's the x coordinate of q. So for the d part, R is enclosed by the graph f, which is ln 5x over kx, the x-axis and the vertical line through the maximum point P and the point of inflection Q. So we have this scenario. Given that the area of R is 3, find the value of K. So we are going to deal with the area under the graph. So it is integral. So here we know the x coordinate of P, which was 1 over 5 e, and Q x coordinate of Q was 1 over 5 e to the power 3 over 2. So basically the area of R is 3, and with the help of integration we can write 1 over 5 e to 1 over 5 e to the power 3 over 2 fx. Fx is ln 5x over kx, dx is 3. So we can see it is not a single function, so we'll use the substitution here. Substitution is valid here. K is a constant, we can send it out. Ln 5x as, let's say, u. If we take this as u, we'll get 1 over x, because ln 5x is one differentiation of ln 5x is 1 over 5x into 5, so basically 1 over x. This equals to du over dx, or we can write for the substitution as du as 1 over x dx, and we need to change the limits. So when x is 1 over 5e, u would be ln 5 times 1 over 5e, these two got cancelled, ln e, which is 1, and when u is 1 over 5e to the power 3 over 2, the u would be just ln e to the power 3 over 2, basically, which is 3 over 2. So the integration, the complete integration become 1 to 3 over 2, 1 over k, I will take it outside because it's a constant, and then this become, after substitution you got u, and 1 over x dx is already du, so it become du. This is given as 3. Now integration of u is 1 over 2 u square, So I can write 1 over 2k u squared, and the limits 1 to 3 over 2 is given as 3. So from here we can write as u squared, that is 9 over 4 minus u as 1, so it is 1 equals cross multiply, this is 6k, so this becomes 5 over 4 equals 6k. So finally we got k value as 5 over 6 times 4, that is 24. That's the value of k. So here's the 11th question, A part. Express minus 3, negative 3 plus root 3 iota in the form of r e to the power iota theta, that is Euler's form, where r is greater than 0, we know it is modulus, and theta is more than negative pi and less than equals to pi, which is argument. So we know how to find it, because in this case we only need to find the r and theta, and here the r is the modulus and the formula for this is square root of the sum of the square of each component. Components means this is real component and this is imaginary, so square of negative 3 is going to be 9, and plus square root of root 3 is 3, so basically we got this thing as root 12. And now we need to find the argument. So argument theta is basically arc tan y over x, so it is root 3 over minus negative 3, and since we can see this point is, this complex number is in the second quadrant, second quadrant, and for arctan the value of the principal value of arctan varies between negative pi by 2 to pi by 2, so that will give me the value in the fourth quadrant. So we can write this directly as pi and plus, and then it is arctan. We can simplify root 3 over 3, it can be written as negative 1 over root 3. So this is going to be pi plus, because the value we will get from the principal value of arctan would be in the fourth quadrant, and we need the answer in the second quadrant, so we have to do the plus pi. So this become pi, and this value is negative pi over 6. So finally we got this thing as 5 pi over 6, and hence the negative 3 plus root 3 iota in the Euler's form is root 12. Root 12 also we can write it as 4 into 3, which is 2 root 3, but that's fine. I will write in this form itself, root 12 e to the power 5 pi over 6 iota, and that's the answer for this part. So for the next part, let the roots of the equation z cube equals minus negative 3 plus root 3 iota be u, v and w. These are the three roots of this equation. And B part question itself is find u, v and w, expressing your answers in the form of r e to the power iota theta. So where r is of course greater than 0 and theta in between negative pi to pi. So before starting this question, we need to understand that we are actually going to find the cube root of negative 3 plus root 3. First of all, I will write this from the A part. Z cube can be written as root 12 e to the power 5 pi over 6 iota. We can rewrite this thing as 12 to the power 1 by 2 e to the power 5 pi over 6 iota. Z is going to be the whole to the power 1 over 3 and 12 to the power 1 by 2 e to the power 5 pi over 6 iota. It is 12 to the power 1 over 6 e to the power 5 pi over 18 iota. Till here without the De Morgan's theorem, and then we need to think of it. I'll explain it using this diagram where we can see the roots will always be equidistant from the center, as well as it will the angle between each root has to be same. if there are 3 roots, then we will divide the 360 degree into 3 parts, and then each angle has to be 120 degree. We'll see 120 degree, that is 2 pi by 3. So if we look at this, so we have U as this point and V as here and W is here. So we can see it is actually going to form a circle. If we draw a circle with the radius is of course the modulus, which is 12 to the power 1 over 6. So this root will always lie on the circle, and they are going to be equidistant. The vector which represents this complex number is going to be the angle between them would be equal. From here, if we take this as U, if we take this angle as complex number as U, 12 to the power 1 over 6, e to the power 5 pi over 18 iota, then the V would be the next angle. Just the modulus would be same because the radius of the circle is same, so modulus is going to be same, and next angle would be the next argument is like you are adding 2 pi by 3. 2 pi by 3 means 120 degree. So it's like 5 pi over 18 plus 2 pi by 3 and then iota. And we simplify it as 3 into 6, so 18, so 12, 17, it becomes 12 to the power 1 over 6, e to the power 17 pi over 18 iota, that's the V. And for W, we will again either we add it or we subtract it, and we know the argument can never cross the pi, so we'll better subtract it. So W would be 12 to the power 1 over 6 because it's a modulus, and then e to the power 5 pi over 18 minus 2 pi over 3 iota. So this becomes 12 to the power 1 over 6, e to the power 5 minus 12, it is negative 7 over 18 pi. Oh, not pi, iota. Yeah, pi iota. That's the V, U, V and W. I hope it's clear. Let's discuss the next part. So on an Argand diagram, U, V and W are represented by the points U, V and W capital respectively. Find the area of the triangle U, V and W. So I will again refer that diagram. From there we can see. So from here we can see that if we need to find the angle, find the area, finding the area means it's easy to find that area of one triangle, and then we multiply by 3, and we know the area sign rule because we have the two sides and angle between it. The angle between is going to be 2 pi by 3, and the radius here is 12 to the power 1 over 6, so it's easy to find the area of the whole UV and W, triangle UV and W. So I guess the area we can directly write as area of UVW is going to be 3 times area of if we take U and V, this 2, so and origin as O, so area of triangle UOV, and that is going to be 3 times area of triangle is half into first side, which is 12 to the power 1 over 6, and second side again 12 to the power 1 over 6 because they are the modulus, same distance, and then sine of the angle between it, sine of 2 pi by 3. So this become 3, so 3 over 2, 12 to the power 1 over 6, 1 over 6 is 1 over 3, and then sine of 2 pi by 3. Sine of 2 pi by 3 is sine pi minus pi by 3, and which is sine pi by 3. Sine pi by 3 is root 3 by 2, so it is root 3 over 2. So finally we can write our answer in so many ways, but again 12 to the power 3 doesn't look good, so we will write in a one format. So it become 1 over 4 3 times 3 into 3 to the power 1 over 2, so it becomes 3 to the power 3 over 2 and to 12 to the power 1 over 3. We can also write in the simplified form with taking the 12, and from 12 we can take out 3, and but it's fine, we can leave your answer because they haven't asked for any specific type. So I hope it's clear. Next part, for the next part we need to see that by considering the sum of the roots u, v and w, show that this is there. And we know the equation we started with was z cube equals to -3 plus root 3 iota. If we take it one side, we get it as z cube plus 0 times z square plus 0 times z plus 3 minus root 3 iota is 0. And now the roots are u, v and w, so it means we know the sum of roots is going to be minus b over a, and here the b is 0, so this becomes 0, means we got u, v and w as 0, and we had u as okay, I will write first of all as u plus v plus w as 0, and u was 12 to the power 1 over 6 e to the power 5 pi over 18 iota, plus v was 12 to the power 1 over 6 e to the power 17 pi over 18 iota, and plus 12 to the power 1 over 6 e to the power -7 over 18 pi iota. This equals to 0. So we can take 12 to the power 1 over 6 common, we can factor out it, and then we know the Euler's formula. E to the power iota theta is e to the cos theta plus iota sin theta. If we split the real part and imaginary part, we'll be left with cos of cosine 5 pi over 18 plus iota sin 5 pi over 18 plus cosine 17 pi over 18 plus iota sin 17 pi over 18 plus cosine 7 pi over -7 pi over 18 plus iota sine -7 pi over 18 equals to 0. And we know the right hand side is 0, we can rewrite thing as 0 and 0 iota. And if we just compare, because we need the cosine term, so if we compare the real parts, so real part has to be 0, means cosine 5 pi over 18 plus cosine 17 pi over 18 plus cosine -7 pi over 18 equals 0, which is very close to. Now we know as cosine of negative theta is same as cosine theta, and hence we got this thing as cosine 5 pi over 18 plus cosine 7 pi over 18 plus cosine 17 pi over 18 is going to be 0. That's the answer. I hope it's clear. Let's discuss the next part. And here is the last question of this paper, question number 12. The function f is defined by fx equals e to the power sin x, and a part is find the first two derivatives of fx and hence find the Maclaurin series for fx up to and including the x square term. So here first of all we'll find the first two derivatives. Fx is given as e to the power sin x, and hence f prime x is going to be, first of all it is exponential function, so e to the power sin x become e to the power sin x, and then we'll multiply by the derivative of sin x, which is cosine x, and then comes the double derivative f double dash of x. It is going to be a product of two functions, so we'll use the product rule. So first we'll write e to the power sine x as such, and derivative of cosine x is negative sine x, and then plus, now this time cos x as such, and then derivative of e to the power sine x, we already know it is e to the power sine x into cosine x, so it is squared here. So we got the double derivative, and now in order to use the Maclaurin series we need the f of 0. So from here we get sine e to the power 0, which is 1, and f prime of 0, we have e to the power 0 into cosine of 0 is 1, so again 1, and f double prime of 0 is going to be negative, first term has the sign, so sine of 0 is 0, so this becomes just 0, and the second term is cosine squared x, which is just 1, so e to the power 0 is again 1, so finally we got this thing as 1, and hence the Maclaurin series is going to be e to the power sine x equals first f of 0 plus f prime of 0x plus f double prime of 0 x square over 2 factorial and so on. We need to just write till x squared, so this become 1 plus x squared over 2. So that's the Maclaurin series for fx till first three terms. So here's the b part. Show that the coefficient of x cube in the Maclaurin series for fx is 0. Okay, so we need to see the double derivative first of all, because we know the x cube coefficient will always come with the f triple dash of 0. So f for triple dash of 0, if the f triple dash of 0 is 0, then only the coefficient is 0. So here we'll find the f triple dash of x by differentiating this f double prime. It is going to be, we'll do it one by one. So first negative sine x into derivative of e to the power sine x is going to be e to the power sine x into cosine x, so I'll write cosine x here, plus means there is already minus, so I'll put it as minus, and then now the derivative of sine x, which is going to be cosine x e to the power sine x. Then the derivative of the second term, again two terms, so we'll use the product rule. It is going to be cosine square x. I'm not going to write square in the beginning because I know the derivative of e to the power sine x is going to be e to the power sine x into cosine x, so this makes it cube, and plus now that we'll differentiate cosine square x, which is going to be 2 times cosine x sine x, and then e to the power sine x. Now this is the coefficient of x cube in the Maclaurin series, so it is going to be f triple dash of 0. So here the first term is 0 minus 1 into e to the power 0 plus 1 into e to the power of 0 minus there is a sign, so it would be 0 again. So finally we got as negative 1 plus 1, which is 0. So we can say from here the coefficient of x cube in the Maclaurin series, which is actually f triple dash of 0 over 3, is going to be 0. That's the solution for it. Now for the next part, we can see using the Maclaurin series for arctan x. So we are going to use this series and e to the power 3x minus 1. Find the Maclaurin series for arctan e to the power 3x minus 1 up to and including the x cube term. So we know already that e to the power x is 1 plus x square over 2 factorial plus and so on. So it means from here we can write e to the power, this because the composite function, e to the power 3x will become 1 plus 3x and then x squared, so it become 9x squared over 2 factorial, that is 2, and so on. Okay, we need the cube, so we can write one more, but I don't think it would be required, but it's okay, we'll write it. The third one is x cube over 3 factorial. So here the 3x cube is going to be 27x cubed over 3 factorial, which is 6, plus and so on. So from here we can write e to the power 3x minus 1 as 3x plus 9 over 2x squared plus, we can cancel this with 3, so it is going to be 9 over 2 again, x cubed plus and so on. So that's the e to the power 3x minus 1. Now arctan x, we can look at the formula booklet to get the arctan x. Arc, it is given always. So arctan x is x minus x cubed over 3 plus x power 5 over 5 and so on. So if we include e to the power 3x minus 1, so this gives us arc tan e to the power 3x minus 1 as x, in place of x I will use these first three terms, 3x plus 9 over 2x squared plus 9 over 2x cubed minus, so this is cubed, I will write just the first term and the second term, 3x plus 9 over 2x squared and then whole cube over 3, because we need the x cube terms and it will give one x cube term, and then plus x to the power 5. So it is of no use because the terms will be of terms more than x power 3, so we'll leave that. So this become 3x plus 9 over 2x squared plus 9 over 2x cubed, and then for the cube we can take just 3x common from here and rest are going to be more than that, so we'll leave it. So 1 over 3 into 3x whole cube is just 27x cubed, and we'll ignore the rest of the terms. So finally we got this thing as 3x plus 9 over 2x squared, and here this is going to be 9, so 9 over 2x cube minus 9 is going to be minus 9 over 2 again, minus 9 over 2 x cube, because it would be 9 2s are 18, 9 minus 18 is negative 9, so this is the answer and rest would be ignored because we need to write till the cube. I hope it is clear. So here's the last part, hence or otherwise find the limit of fx minus 1 where x tends to 0, arctan e to the power 3x minus 1. So we have two rules. First one, we can simply put the value here, and if we have already expanded it, so we'll use this. So this become limit x tends to 0 fx, if I can recall, it was 1 plus x squared over 2 factorial and so on. So yeah, 2 factorial, and then it was 0, so we ignore it. And if we take this minus 1 here, so we are getting x plus x squared over 2 factorial plus and so on. And the denominator is arctan e to the power 3x. We have just got this thing as 3x plus 9 over 2x squared minus 9 over 2x cubed. So we can take, if we plug the value of x 0 here, it will be 0 over 0. So it's better to factor out x from the numerator and denominator both. So we're left with x tends to 0. X factoring out, it is 1 plus x over 2 factorial and so on. And denominator, we can take 3x in place of x, but that's fine. We'll factor out just x. It is 3 plus 9 over 2x minus 9 over 2x squared plus and so on. We can cancel them, and now we plug the value of x in this, so it becomes 1 over 3. So that's the limit. And that's the end of this paper. I hope it was of some help. Let's meet again in the next paper. Till then, thank you so much.